499 is a number of observation, or we can say number of rows, and we have 10 column, that means 10 features. With pandas we can describe the data in number of terms, like if we want to say for example head of data. Okay, so we can see the head, it means it prints the first 5 elements. Here you can see the user ID. Each Twitter user has their user ID created at when the user created his account and when his data was collected. uh, this really helps to count the age of accounts users. A number of following, these are from user timeline, these features can be extracted from user timeline. And number of followers, these features has already been collected from the profile. I will also show in my next videos like how to collect this data from Twitter. And number of tweet, the number of tweet user has demonstrated. Length of screen name, in Twitter it has every user has a screen name. This is the length of user name. Length of description, since here is also like people has to use a kind of perception or intelligence, like whether it is a kind of features which does it make any kind of behavior phenomenon or not, like, or for example user ID, it's just the information, it cannot be features that can be fed to the machine learning algorithm. Here we have spammer or not. This spammer or not is actually output level. So while data collection approach, we already know the output, like we go their timeline and we see them how they are behaving. For example, if these kind of features are there, this is a spammer. Or we know the spammer, this 0 means non-spammer, legitimate users, 1 means spammer. So we know the non-spammer and we collect their all the data. In machine learning algorithm, what happens is that it's just the branch of artificial intelligence where it knows the history of the data, and it try to know the pattern, or it try to predict about the futures data. For example, in futures, one users we collect all the attributes which does not resemble to here, and we try to find out in which class it belongs, whether it is spammer or non-spammer. So in predictive analytics, we really do this kind of work. So we have made some kind of predictive model using supervised learning algorithm. Let's see what further we can do from here. So we can do a lot of analysis thing. For example, we can describe the data. So your whole data sets can be described. For example, user ID, a number of following. Let's see about the number of tweets. So here we can see the count means a number of observations is 41,499. Among them, like these users have their mean tweet is 1802, and standard deviation is this much. Minimum tweet is 0 tweet. Some users have tweeted minimum, and like 25% of users have tweeted around 49, and 50% of user here, 50% of user has tweeted around 334 tweets. So mostly 70% has tweeted more. So we can see is that the more tweet majority is high, and maximum tweet is this much, 350,453. So this is the way we can describe the data. We can also describe only one data. So let's go further. So for example, we want to know like among 41,499 how many are there spammer and how many non-spammer. So with this value count functions, we can separate the data. So we can see is that 22,223 are spammer, and this 0 means non-spammer, 19,276. Let me briefly describe you how the data was collected by the professor. Is that while collecting the spammer data, he created like 60 honey sport. Honey sports are like inactive accounts which randomly post anything and just follow the people randomly. So he invested 6 months to collect the data, and he found out like a lot of most of the users were even blocked by the tutors in course of time. So he labeled them as a spammer. For collecting non-spammer datasets, non-spammer datasets, Professor just randomly followed a lot of people, and in course of time, he detected that number of users were not uh, blocked by the tutor, so he marked them as a legitimate users. I have done my different approach. I will describe you in the later video. This really depends on the analogy, how pure the data is, or something like this. So here we can do a lot of kind of queries. For example, if I'm interested like the num for the total data says like number of following is greater than 0 and number of followers is less than 20. Let's see, let's count these users. So we can have this table. It's exactly like selecting some queries, doing some SQL thing or something like this. Like we can do whatever we want. So we can see that we have just four rows. So for only four observation has the number of following greater than thousands and number of followers less than 20. So this kind of analysis we can do on Twitter on these pandas. So here I want to print something. I want to draw some graph to show visually. For example, new features that has been used by the many resources is called reputation. Reputation is defined as the ratio of number of follower by sum of number of follower and number of following. So it is assumed that only a legitimate user has the dominance of this feature. So we can see from this graph also uh, after 0.5 uh, legitimate user only have dominance on the reputation. So this gives the visualization or intuitive statistical meaning how the feature is important when you are going to use in your machine learning algorithm. So here in this part we can see is that in low reputation area uh, spammer has the dominance. So let me further filter your data. For example, I'm interested to know like how many among 41,499 users, how many users has the reputation greater than 80%. So among their 1,757 user has reputation this much. So let me further know let among them how many spammer has the reputation this much. So among 1,757, only 101 users has the reputation 80%, and for the legitimate users, you can see 16,000. Uh, so there is like more than 80%. Almost all legitimate users only have dominance on these features. Preparing X and Y using pandas. I mean, in machine learning algorithm, we have to prepare a matrix, a pandas matrix. A panda is a data analytics tool. It is built on top of NumPy array. NumPy is a numerical Python. It is a compiled version of Python. Because Python is an interpreter language and it's a very slow, which runs line by line. Uh, and the NumPy is a compiled code. It's based on C programming, and it makes really fast programming. And Pandas data frame also are NumPy array, so it's really fast. So here what we make is that we make a X matrix where we give the number of features that we want to use, and we give an output level. We give one output response value. So let's run this. So we can see is that uh, the shape is this much 41,499, and columns feature column is 4, and the print we can see the type is pandas data frame. So from here, let me give you one very nice concept. Here we have 100% of data. For example, this data is 100% data. So what we do from here is that we just split the data into the 80% and 20%. From the 80% data, we teach our classifier or a machine learning algorithm, like providing these kind of features. Our output level is this one. So in 20% of the data, what we do is that we don't teach our classifier with response level. We just give the features level. We just give the features, but we don't tell the output level, or we don't tell the response. We aux classifier. Now it's your time to predict, and we compare its prediction with the data, with the response level we already know. Since in the 100% data we already have the response, so it really helps to predict like how it works to do the out of sample data. So now the data has been splitted, so we can see the splitted data format. So you can see X train uh, train data from the 41,499, we have splitted 31,124, and train data sets is this much. So X train, Y train, X test, Y test. So from our uh, total 100% data, we splitted the data. uh, Let me just describe you from the graph here. For example, okay, okay, so if we have this is as 100% of data, so we use this much 0 1 2 along with this spammer or not, this response value. We use this data to train the model, and the rest data, for example this much, uh, 3 and 4 rows, for example, we take up to the this limit, and we give these features, and we tell to predict this response value. For example, here response is 0 and here response is 1. Since here we already know the response, but at this case, giving these two rows, we don't tell this response value, we ask our classifier to predict it, and we compare with the actual response value. So this is the way we really compare the performance parameter of the classifier. So let's do it. How does it happen? So we have split it, the shape as well. So here is some features that we do use for the verifying performance parameter of the classifier. For example, accuracy. It really gives you the overall how accurate the model is, and precision is the ratio of true positive by true positive plus false positive. It really gives how exact how exact the data are, like how precise the classifier is. And recall, which is also known as sensitivity, it really tells like how much relevant area our classifier has covered. So here these terms I will describe later on as well. So demerits of train test split, there is some demerits as well, I will describe you. The demerits is that in train test split, we for example, we generally take this red as a training model and this gray as a testing model. So if this red data sets are really statistically really varied from this green data sets, the output, the percentage or the performance classifier metrics might come higher, but it really does not indicate the overall nature. That's why we split into the tenfold, and for each time we use this red to train the model and green to test the model. You can see these pictures, for example. So we can also take these pictures on the local computer. Here in Python, what happens is that if you use here markdown, you can do like HTML coding, and if you do here as a code, you can do as a coding thing. So in the markdown, here this is yespipe.posting.img. Here if you upload the pictures, so it really helps you if you change your machine your pictures will come. So here in this case, if you host it from your local machine, while changing the computer, the code will not work. So if it is from the web, it will come as always. So let's see one classifier. This is key nearest neighbor classifier. It really works on the importing given from the nearest neighbor. So here we have a scikit-learn. Scikit-learn is a machine learning library, basically written in a Python. It allows most of the researchers to use the machine learning easily. We just need to import it. So from scikit-learn, we import this key classifier, and for metrics for evaluating a lot of features. And here we instantiate the model. You can see that I have just instantiated the model with giving the nearest neighbor value is equal to 1. And with this x train and y train, I have fit the model. So it is not, x train is not 100% data, it is 80% of data. So using this x train and y train, now I tell my classifier to predict for the x test. In x test, there's no response value. So I want to know the response value here. So I save it here, y predict. And now I print the accuracy of the classifier comparing with the y test value. Y test means here while splitting. Again, let me take you here. While this y test we already know, but using this x test we try to evaluate from the classifier y predict, and we compare these two value, how accurate this classifier has done it. So let me run this. So classifier is 81% correct. So what does it mean is that out of this 20% of data, so among them 80% it has predicted, as we know its output response. So here is the parameter like precision, recall, F1 score, and support. So average precision is 81%, average recall is also 81%. So this F1 score is a harmonic mean between this precision and recall, since we have to balance these features. And this support is basically this row count. If you add this two value, it will count this above. This total value is the 20% data that we use to perform the classifier. So in a confusion matrix, it really gives a pictorial view of the data, like how the classifier has worked. Let me describe you these things. Here, this upper left part of 3857, this is called true negative. Here 9960 is called false positive. Here 969 is called false negative. Here 4589 is called true positive. So in our case, true positive is a spammer. So what do you mean by true positive is that a classifier predicting a true value. For example, uh, we know the output is true, and classifier has also predicted as a output as a true. So this is called true positive. And true negative means legitimate user. We know response value is non-spammer or legitimate user, and classifier has also predicted non-spammer. This is called true negative. And what do you mean by false positive is that falsely predicted positive. False positive means classifier has predicted as a positive. A classifier has predicted as a spammer, but actually they are not a spammer because we know the response value. So they are called false positive. And false negative means a classifier has told they are legitimate users. A classifier has told they are 0, but actually they are 1, or they are spammer. So this is called a false negative. So it's really confusing. Might be it is named as a confusion matrix. So so here we can see overall accuracy is 81%. How it is done is that we use the 80% data to train the model and 20% to test the model. So if 80% data highly deviate from the 20% data, this accuracy might come higher, but it will not be generalized accuracy. That's why we use cross validation. Let's see what happens in the cross validation. Actually, in cross validation, we get the accuracy for each tenfold. So you can see the 81%, 82%, 82%, 82%, 82%, 81%. Here is also 80%. So from all these splitting here, you can see this is average value of all of these 10 value. So here you can see on the pictures. Here each case we try to evaluate the accuracy, and from here we generalize. So it is a generalized accuracy. So we can say is that our classifier is 81% correct when it has to work in the out of sample data. Here is another classifier. It's called decision tree classifier. Decision tree classifier really works on while uh, increase in information level or decrease in entropy level. Here you can see the decision tree. It's a kind of classifier, supervised learning algorithm to predict the data. So here I don't have to, I have done the same, exactly same process, just importing the decision tree and instantiating the class and then fitting the model and then predicting the new class and then evaluating this performance matrix. So I have seen the here is also 81%, and this confusion matrix value are different. So let's evaluate the cross validation also. So here you can see with the cross validation, this accuracy is like almost similar. So we can see is that the data is randomly distributed, or data is statistical distribution of the data is, I mean, statistical distribution of the data is smooth. Like here you cannot see, like for example here 50%, 90% like this. You are not seeing this thing. Naive Bayes, this is another classifier. It actually works on the principle of conditional probability or posterior probability. So let's just see the output level. Okay, here also I have got like almost 81%. So here you can see the change in the output level. So let's run the random classifier also. This is the random forest classifier. It's a combination of the decision tree. There is actually a problem with the decision tree. Like if the decision tree with change in the data sets, it highly changes the output level. For example, if the decision tree is trained deeply, it try to learn a complex model, like overfitting the training data set. What do I mean by overfitting is that here I get the accuracy high, but when it has to perform for the out of sample data, it does not work well. So this kind of state is known as a overfitting. So with the random forest, okay, I got the higher percentage here accuracy. You can see from 81 to I got 85% accurate model, and precision is 86. Recall is also 86. So you can see the value of confusion matrix here. Here with the confusion matrix, what you can see is that the less the value of false positive and false negative, the good the model is. So let's evaluate the cross validation as well. Okay, this is star means it's working. This is BG. So here you can see the variation 84%, 86%. While this doing this cross validation, I got the average value is 85%. So here this using this is called features. For example, let me describe you. Here this number of following, number of follower, number of tweet, length of discriminant, they are called features. So this is the initial level features that we have collected or the professor has collected, but I am interested here to make the new features from existing features as well. So okay, so I have added the one feature called longevity features. A longevity features is the difference between the collected date and the created date. So it gives the what is the length of the period that user existed already in the Twitter environment. The hypothesis is legitimate user have a longer legitimate users have longer longevity than spammer user. So I have collected a new features. It's called uh, longevity, and let's collect a second features, tweet per day feature. Tweet per day features is collected by dividing the number of tweets by the age of account. So if we divide the total number of tweets by age of account, which is collected in the day, as you can see here by using this uh, various functions on the pandas data frame. I have uh, I have collected these features in the day format. I'm sure I might have run this. Okay. Now, okay, what is this? Tweet per day features also. Here I have described this after collecting these features. So tweet per day features, you can see the mean tweet is 13 and standard deviation is this much. 20% of the users has this much of tweet, 50% has this much of tweet, 70% has this much of tweet, and maximum tweet is this much. So it gives you a little bit of what is the statistical if you want to interpret the data that you have collected on. Another feature is number of tweet by the number of follow. So this features is like I will describe you these features with the visualization. So we have to drop some infinite values that will really disturb while working on. Another feature is age of account by number of following. The hypothesis that is used is that this is very low for the spammer and very high for the legitimate case. Okay, and again dropping the some here. I have just used for dropping the infinite values because it will really disturb while working on. Now let's just separate the spammers and the legitimate users. Okay, this much is spammer data and this much is the legitimate data. Length of description features also. Let's explore the age by following features. In the age by following features, the the supposition or the like what we have supposed is that for spammer hypothesis is spammer age is low and the following number is high. So I mean in the low period of time they try to follow as much people as they want. So the low by high the result will be low. And for legitimate users the hypothesis is their age is high. Even though their age is high they only follow a person whom they are interested in, so the result is high. So it's only a we don't know the results, it's only like a hypothesis that we have made. So let's test this hypothesis whether it's actually true or not. For example, in the legitimate case, let's try to know the value. So out of like 18,605 the mean value is 8.5. So let's just consider only at the mean value. The mean value of the age by following is 5.8. So for the spammer case, uh, this is on the total mean of 18,610. For the spam data we can see 21,736. The mean value is 0.33 and 5.8 is like 17 or 18 times greater than this value. So we can see is that this feature really helps us to distinguish between a spammer and non-spammer. I can show these features visually as well. And establishing the relationship between number of tweet and the number of followers. Let me draw the graph. So here I have drawn a graph for the legitimate users. Here what I want to show here is that uh, legitimate users, when post their tweet, they also get the number of followers. So with increase in x-axis, there is also increase in y-axis. You can see the density here. But for the spammer case, even though they post a lot of tweets, but they don't get the users. They don't get the users, they will follow them back. That's why even though there is a lot of increase in the x direction, there is hardly increase in y direction. So number of follow is very low. So this ratio is also very important while distinguishing between spammer and non-spammer. And I just describe you a number of following by the age of account. Let's see this visually. So this is for the legitimate users case. In the legitimate user case, what's happening here in this figure is that uh, among this like 20,000 half data, 20,000 data, when their age increases, the number of following is that the people they are following is not so much high. Here you cannot see a very high density here in the y direction. But here in case the spammer, let's see the data. Let's see the figure. And this figure you can see is that when their age increases, you can see is that in x-axis when their age increases, the y-axis highly increases. What does it mean is that with increase with making the account, they start to follow as much as possible people. So this visualization really gives you like how important the data that you have made to feed your classifier is. Now what I do here is that I use all the new features that I have collected and again try to run the same model, and I try to and find out whether I will come up with a better performance parameter or not. So okay, now I have considered all the features. Now I again do this splitting process. Okay, I have done this splitting process as well. Now let's run the model, this kn. Okay, this star means working. Now what we have got now here, I have got the 89%. So wow, it's really increased. So we can just say this it overall accurate model or average accurate model, because defining this actually this terms also relates, or it is also relevant according to the our requirement. Now the decision tree, let's run this decision tree. Okay, it is 86%. This is also increase in overall accurate model. With increase in this other thing also get increased. You can see that. And this I already told you that the value of false positive and false negative has increased. This is Gaussian model. With Gaussian model I got like 87% overall accurate model. No, this is from trend test split I got 87%, but average is 89%. So you can see the variation here while working with this model. And the random forest. Wow, with the random forest I got like almost like 90% here and 89% here. So last time, if you remember, I have got with the random forest. I can show you right now also. Where is the random forest? Yeah, you can see that with the random forest I have got here 85%. Random forest 85% here, and with the cross validation I had got like average 85%, and at last I got like 90% or 89.7%. So with use of the new feature engineering, which is called the feature engineering after feature selection, I have really shown the increase in performance parameter of the model. This is the end of this video. I will show in next video that I have followed the different approach for the data collection. I will show the framework that I have made to collect the data from the Twitter environment. You need internet connection to do that. I really thank you all to see my video. Thank you everyone. I'm going to stop my video.